Welcome to solverfy.
Okay, so we're doing chapter 23, problem 17. And this problem says, suppose the end of your finger is charged. Okay, so part A, estimate the breakdown voltage in air for your finger. Okay, so we'll use the same approach as we've done before in examples 23.4/23.5. And the way we do that is we know that the potential, the surface, is given by the radius R naught times the breakdown voltage, or breakdown electric field. So since our finger is in air, we know that the breakdown voltage in air is given by 3 times 10 to the 6 volts per meter. And what do we use for R naught? Well, we're going to assume that the width of a finger is about a centimeter. So we consider the fingertip to be part of a sphere of diameter 1 centimeter. So that means our radius R naught here is going to be 0.005 meters. So if we multiply these together, we get what our voltage at the surface of our finger is, and that comes out to being 15,000 volts. Cool. Part B. Part B asks us about what surface charge density would have to be on your finger. Okay, so we should know that the surface voltage or potential is given by Q over 4 pi epsilon naught R naught squared, or sorry, just R naught squared as if we're talking about the electric field. So now let's write the total amount of charge on your finger, assuming it's a sphere with a charge all around the surface. So we assume it's a sphere with surface area 4 pi R naught squared times the surface charge density. So this whole quantity up here is going to be equal big Q. And we divide this by 4 pi epsilon naught R naught. And we should see that V surface becomes R naught sigma over epsilon naught. We can rearrange and solve for what sigma is by saying sigma is V surface times epsilon naught over R naught. So we can plug that in now. So 15,000 volts times epsilon naught all over 0.00, oops, one too many, 5 meters. This is Coulomb squared per Newton meter squared. And this all comes out into our calculator to being a surface charge density of 2.7 times 10 to the negative 5 coulombs per meter squared. Cool.